Hello everyone, today we're looking at Unit 3, Lesson 1. We're going to look at negative and zero exponents today. So yesterday we looked at a couple different exponent rules. We looked at our product exponent rules, we looked at our quotient exponent rule, or power rule, and then we looked at our power of a power rule. Today we're going to focus on what does it mean if we have a negative exponent or if we have an exponent of 0. So let's start with our quotient rule, which we saw yesterday. And that will kind of lead us into a zero exponent and a negative exponent as we get there. So remember, if we have x to the power of 3, and this means divided by x to the power of 2, then we're going to keep our base the same, and we're going to have our exponents be subtracted. So I keep saying this word, and I just want to kind of make point of it. This is our base. So let's write that. This is our base. And our base is whatever number or variable is being raised to an exponent. And I'm going to refer to our base often in this lesson, so I just want to make sure we're comfortable with that terminology. Okay, so this is going to become x to the power of 1, and we can just write this as x. We don't need to write or show the 1. Okay, let's try the next one. So this time we're going to have x, and then we're going to have 3 minus 3. Well, that's going to end up being x to the power of 0. So what does that really mean? Well, let's put in some numbers and see if we can kind of come up with a general rule for what happens when we have some base raised to 0. So let's sub in 3. Let's sub in x equals 3 and see what that gets us. So if we have 3 to the power of 3 divided by 3 to the power of 3, okay, well 3 to the power of 3 is 27, and we have that in the denominator as well. So that means division. Well, what's 27 divided by 27? It equals 1. So that's telling me that the general rule, whatever I plug in for my x values, is going to equal 1. So these mean the same thing. So x to the power of 0, if we plug any number in, we should always get 1. Okay, so x to the power of 0 is always going to equal 1, which brings us to this zero exponent rule. So any base except for the base of 0 with an exponent of 0 is equal to 1. So a to the power of 0 equals 1, no matter what a is, as long as it's not 0. So let's look at some examples. So if we had y to the power of 0, that's going to equal 1. If we have 632 to the power of 0, it's going to equal 1. Okay, we could even have a term that has some variables and other powers on it, still going to get us to 1. So if we had 6x squared y to the power of 4, I took that whole term and I raised it to a 0, right? I'm going to distribute that 0 onto my bracket, onto everything inside that bracket. So I'll have 6 to the power of 0. Okay, well, if it's a power of a power, we multiply. So 2 times 0 is 0, and 4 times 0 is 0. So that's all going to boil to 1, because everything's being raised to a power of 0. Okay, and then let's just make note one more time of that exception to the rule. So if we have 0 to the power of 0, that does not equal 1. Okay, because you're raising nothing, right, to a power of 0. So 0 to the power of 0 is just going to equal 0. Okay, that really is just the difference there. So let's look at that last quotient rule and see if we can kind of tie that into our other exponent rule we're going to learn today. So if we have x to the power of 3 divided by x to the power of 4, well, my quotient rule says that I'm going to subtract the top exponent from the bottom exponent. Okay, well, when I do that, I get x to the negative 1, right? Because 3 minus 4 is negative 1. So what does that really mean? Let's see if we can write out our x terms in expanded form, and maybe that'll boil us down to something that looks a little bit more familiar. So let's write in expanded form. So instead of x to the power of 3, I'm going to write x times x times x. And in my denominator, I have 4x's being multiplied. Okay, so if I wanted to simplify this, right? Remembering that all of these have an exponent of 1. We don't need to write it. It's just implied it's there. Okay, power of 1. Well, this x is going to cancel out this x. This x is going to cancel out this x, and so on. All we're going to be left with is x in my denominator. So in my numerator, I'll have 1, and in my denominator, I'll have x to the power of 1. Okay, so again, because we've just written an expanded form and then boiled down our division, we can say that these are the same thing. So x to the power of negative 1 is equal to 1 over x to the power of positive 1. So the rule here is basically saying, which I'm going to circle these, okay, is that any base with a negative exponent may be written using a positive exponent and placed in the denominator of a fraction. So basically, if we flip the base, then the exponent is turned positive. So you can see here, when we have a to negative m, if we flip the base, okay, m is positive. Okay, so when we flip it, our m becomes positive there. Right, so it's no longer negative, it's a positive. Or if we looked at it the other way, so say we had a fraction with a negative exponent, right? If we wanted to make that positive, again, we're going to flip our base, and it's going to become positive. Okay, so you can go the other way. You can flip the base again, which would just make it a over 1, and it switches the exponent to a positive m. Okay, and the last example I want to show here, remember, because we keep saying we're flipping our base. So if we had x over y, if we flip, right, then that negative exponent n becomes a positive n. So again, we flipped it here. Okay, so if we looked at some examples with some actual numbers, so if we had x to the power of negative 3, right, if we wanted to write that as a positive exponent, okay, then we could say 1 over x with a positive 3. That's how we write it, as a positive base. So if we had, let's say we had 1 over 3 to the negative 2. So once again, I'm going to flip my base. So it's going to become 3 instead of 1/3. And then my exponent becomes positive. Okay, well, we know what 3 squared equals. 3 squared equals 9. Let's look at a few more. So if we had 4 to the negative 2, we could write that as 1 over 4 squared. And again, we could continue to simplify that. So 4 squared is 16. So we're saying 4 to the negative 2 equals a positive 1/16. Let's look at if we had a fraction, something other than a 1. So if we had 3/4 to the power of negative 2, in order to write that as a positive, we'd flip our base. So it become 4/3 squared. And then we can distribute our exponent. So we'd have 4 squared divided by 3 squared, which is 16 over 9. Okay, so that's how we work with negative exponents and how we work with zero exponents. So let's take a look at some examples. So knowing what we know about negative exponents now, we're going to see if we can solve equations that have that deal with exponents. So we've all seen how to deal with if we have a squared in our, or an x squared in our expression, in our equation, how we solve for x, right? We saw this in particular in Pythagorean theorem. We would just take the square root of both sides, and then we would say x equals 9. Okay, but we could also, instead of doing this, let's use our exponent laws instead. So use exponent laws. So what I mean by that is if we can get our base to be the same, then we can infer what x is going to equal. So if we have x squared equals 81, well, I have to think about how can I write 81 so that it has an exponent of 2? What could I make the base so that it has an exponent of 2? Well, if I was to think about the square root of 81, right, I know 9 squared equals 81. So I could put that on the right side of my equation instead. So now I could say x squared equals 9 squared. So we can see we have the same exponents, okay? So the bases therefore must be equivalent. So must be equivalent bases. So we can say therefore x equals 9. Now, with an example that's simple, of course, we would just take the square root. But I'm just trying to show you how you use those exponent laws, especially when you get into more complicated equations that deal with exponents and variables. So if we look at the next one, we have x to the negative 2 equals 1/16. Okay, so I want to use our exponent laws to manipulate one side of the equation to look like the other. So let's just make a note of that. So we're going to use our exponent laws to manipulate one side of the equation to look like the other side. So if we look at this next example, I want to try to get x to the power of negative 2 to look like 1/16 or vice versa, okay? So if I have x to the power of negative 2, I want to start thinking about, okay, can I make one of these sides look like the other? So I know that, okay, this is a negative 2. Is there some number that I can have 2 as an exponent that equals 16? Right? Well, I know I can write 4 squared, and that would equal 16. So I'm going to put 4 squared in place of my 16th. Right, so I'm replacing 16 with 4 squared. Now my exponent laws tell me that if I have 1 over 4 squared, then that's going to be the same as 4 to the negative 2, right? Because if I flip it, it's going to switch the sign of my exponent. And if I have x to the negative 2 over here, okay, I'm starting to make the two sides look the same. So I have my same exponent. So again, we have to assume that our bases are then equivalent. So we can then therefore say x equals 4, right? Once we've gotten the equation to look the same with the same exponent on them, then the bases must equal the same as well. So let's try another one. So we have 3 to the power of x is equal to 1 over 27. So again, I'm going to try to manipulate one side to look like the other. Most likely I'm going to have to change that 27 because there's not really much we can do with the 3. So I'm going to leave this as 3x. Okay, how can I write 27? Well, I should be thinking about, well, there's 3 on the other side, so I must be able to write 27 somehow with 3 as my base. Okay, so 3 is my base. 3 squared is 9. 3 to the power of 3 is 27. Okay, so from here, 3 to the power of 3, if I want it to look more like the left side of my equation, well, I can write this as 3 to the power of negative 3. Okay, now we have the same base. So we can assume or say, therefore, we also have the same exponent. So if our bases are 3 on both sides, then our exponents must be the same. So we have to say x is equal to negative 3, right? My exponent, x, must be equal to my exponent on the other side of the equation as well, for that equation to be true. Okay, let's look at one more for today. So if we have 1/4 and we're raising that to a power of x, again, how can we rewrite one side of the equation to look like the other? And we're going to try 2 different ways this time. So if we have 1/4 to the power of x, if I think about how can I write 4 as my base, or 1/4, but let's just work with 4 right now, and then we'll see how we can change. Okay, well, 4 squared is 16. 4 to the power of 3 is 64. So that's going to become 4 to the power of 3. Now they still don't look exactly like each other, right? So I could maybe now look at the left side of my equation and think about, can I make it look more like the right side? Well, right now I have 1/4, right? And I can even say this is to the power of 1 down here. So if I wanted to flip it so it looked like a 4, I could say this is 4 to the negative 1 but I still have this x out here I have to deal with. Okay, so then I would use my power of a power rule, and I would multiply my -1 and x together. So this would be a negative x equals 4/3. Okay, so I have my same base, so again, I can assume that my exponent is the same. Therefore, exponent is the same, which in this case then, a negative x, which is my exponent, is equal to 3, but I need to solve for just x. So we're going to go ahead and divide by -1 to get rid of that negative sign, and we're going to get that x is equal to -3. Okay? I want to look at this from a different perspective. So what about if this time we still started with 1/4 power of x and 4 to the power of 3. Okay, but instead of looking and then changing my 1/4 side, let's just leave this alone and continue to work with this side of the equation. So is there something I could do to my base on the right side to make it look more like the left, right? If I wanted to, instead of writing this as a 4, if I wanted to flip it so it looked like 1/4, then we could make this a -1 out here and keep my 3 out here, right? So now it's starting to look more like the left side, but we have to deal with this -1 out here. So again, I'm going to carry that 1 to the outside. So we could say 1/4 x is equal to 1/4 to the -3. So again, now we have our same basis. We can say x is equal to -3. And you can see no matter which way you kind of approached that problem, you should always get x is equal to -3. Okay? That's all for your note for today.